Hey guys, this is Baha, and today I'll be presenting my routing and scheduling project called the Meal Delivery System. For the content of this presentation, we'll go about 5 categories. The first one, we'll talk about the business. Secondly, we'll talk about how the IE approaches the business objective. Third, we'll start talking about how the business objective um, was approached and solution was derived from those models. And then we'll experiment with the model, and finally we'll talk about the conclusions and recommendations. Starting with the business, the restaurant has recently hired an IE student to help develop a meal routing system to deliver daily halal meals to subscribed customers on time and using the least possible delivery costs. The restaurant's main objective is to provide the highest customer satisfaction level, as they want to provide flexibility on delivery times that suits the customers throughout the day. As of now, the business just opened up and they've received about 50 signups from international students around Halifax. And they're not really sure how many drivers they want to schedule or hire and what sort of routes to take to reach all those customers, specifically respecting their preferred time windows. As we approach the problem, two VRP models have been used. The first one was the Excel model using the Garobi engine. The second one was researched online through a website called Rotific, and it's a proprietary code used using Python. Both models were the solutions of both models were analyzed and compared against each other to determine which suits best the business. As for some of the assumptions, the restaurant operates from 8 a.m. to 5 p.m. Customers are allowed to have up to 4 meals per day, with some assumptions assigned to them. Also, customers can pick a preferred time window with their assigned probabilities. The first time window is a morning, and that's from 10 a.m. to 12 p.m., and that's 30% of the time. Early afternoons are from 12 p.m. to 2 p.m. with 25% of the time. And finally, late afternoon is from 2 to 5 p.m., which is the highest assigned probability of 45%. There's also a duration factor, and that is the time it takes to drop off meals from car to the customer or to the building. And that is constrained to between 1 to 5 minutes with an average of 2.5 minutes. Hired drivers will have their own cars with a capacity of 30 meals, and calculated variable cost is 0.315 per kilometer. Using a Python code, we've generated 50 random addresses with a 5-kilometer radius centered in the middle of Halifax's peninsula. And that is on the right side graph. As for the mathematical formulation, on the screen we see the VRP formulation using some constraints. And the first constraint is the MTZ sub-tour elimination. The second sub-constraint is the vehicle capacity constraints that constrains the vehicle from exceeding the limit on its capacity. And finally is the time window constraint, which only allows time deliveries to be delivered between earliest and latest times. For the solution of optimal routes, we've generated 2 routes for both models. The first one on the left side, the Excel model, it ran for 23 seconds of computational time to generate the optimal route of about 5% gap or 5% tolerance level, and it did schedule about 13.6 hours for all 3 drivers with total labor cost of $245. On the other side, with the Routific Python model, it took only 2 seconds to compute, where it scheduled about 4 hours of all 3 drivers with total labor cost of 72.6. I think that the Excel model is about 4 times bigger than the Python model, as order assignment lacked a bit. Order assignments here on the Excel file seem to assign certain drivers to 2 time windows, which created a lot of gaps, and hence it created a lot of break time between drivers. As we can see on the graph here, there is about 1,000 simulations that ran using the assigned probabilities mentioned in the assumption slides, and we've gotten an average of $690 per day in net revenue for the business. Moving on with the experimentation with the model, the Excel VRP model was used to find optimal routes during Ramadan month. Ramadan is the holy month where Muslims fast without eating or drinking, starting from sunrise till sunset. When Muslims break their fast, they expect to have their meals to be freshly cooked and ready to eat. It is assumed that the targeted 50 customers for this experiment were all customers wanting their meals delivered right before sunset. Those customers should be satisfied if they receive their meals about no more than an hour before Maghrib time. This means that the time window width should be 60 minutes. As for the solution, 3 vehicles were still assigned similarly to the Excel and the Pythons from the default months, but in this map we can tell that it's more organized and less chaotic, as the model only focuses on shortest time or shortest path between orders and not really on the time windows, as time windows were very consistent for all 50 customers. As we can tell for vehicle 51, it only focused on the south end of Halifax, while 56 focused on the west side and the north end of Halifax, and finally with vehicle 59 focused on the core of Halifax. To conclude this project, the total number of drivers to hire or to schedule during the normal months, as well as the Ramadan months, is equal to 3 drivers. The Python model was way more efficient than the Excel model due to better order assignments to drivers considering one time window per driver, while the Excel model was scheduling 2 time windows per driver. The second is the faster computational time, with 2 seconds compared to 23 seconds to achieve 5% tolerance level. And finally, Python is easier to integrate a heuristic model that uses an Excel as an input. As for the final slide, Appendix A shows more of detailed solutions with arrival times for all 3 models that were discussed today. Thank you.